This is Algebra 2 with Trig, Unit 4.1. We'll be graphing quadratic functions in standard form. Quadratic function can be written in the form of ax squared plus bx plus c. Now that'll equal 0 if you're solving, or that could equal y if you're graphing. The graph of a quadratic function is going to be called a parabola. That's the U shape that is made while graphing any quadratic. We talk about a parent function, and that's the basic form of any family of functions. So in this case, using function notation, the most basic form would be x squared. So when 0 squared you get 0, 1 squared you get 1, 2 squared you get 4, 3 squared you would get 9, negative 1 squared you get 1, negative 2 squared you get 4. So that's why it curves like that. It never goes into the negatives because you can't square a number and make it negative. For the parent function, the y-axis is considered the axis of symmetry. Often you'll see that as LOS, which would stand for the line of symmetry. Another very important part about the parabola is the lowest, in some cases the highest point, and that's called your vertex. When we're looking at the graph of a quadratic, we can consider the domain and the range. The domain are the x values you could plug into your equation. Every quadratic, you can plug in any number for x. A big number, a small number, a fractional number, 0, negative numbers, any number you can plug in. So you get all real numbers can be plugged in. There's a symbol for that, 2 lines and the rest of the R. That would represent all real numbers. The range, if you notice, the range goes down to 0, but then it goes back up. All the values that are positive, including 0, are being represented in the graph. No value in the negatives are being hit. So our range is considered y is greater than or equal to 0. That's one format we could use to represent a range. You could also say that the lowest point is 0, it goes to infinity, it includes 0, and you can't actually ever reach infinity. So this is just a different notation for representing. You can use either or, you can use them both, whatever you like. You'll really use this in pre-calc. I know you also may have used it some in Algebra 1. We don't seem to use it too much in Algebra 2. Okay, some properties. We're in standard form. So notice how the graph could open upwards, or it's possible for the graph to open downwards. The line that goes right down the center is called your axis of symmetry, or line of symmetry. That's found by x equals negative b over 2a. And the graph is going to cross the y-axis at a point every time. It has to always cross somewhere. It covers every x value, so it's always going to cross the y-axis somewhere. And it's always the c value. When x is 0, that would cross out. When x is 0, that would cross out. So you'd be left with, when x is 0, you're going to have that c value. The graph is going to open upwards if a is greater than 0. If it's a positive number, if a is a positive number, the graph is going to open upwards. It's going to open down if a is a negative number. If a is less than 0, then it'll open downwards. The graph will be narrow if the a value is greater than 1, and it'll be much wider if it's less than 1. We're not talking about the negative numbers. That's why it's absolute values. We're just talking about if it's a fraction, it will be much wider, and if it's a large number, then it'll be much narrower. It goes up much faster. It'll have an axis of symmetry, also known as LOS, with x equals negative b over 2a. You need to know that formula. That's part of the vertex, because to find the vertex, it's going to have the x coordinate of negative b over 2a. Then you substitute in that x value, which is the line of symmetry, and you solve for y. That's how you find the vertex. First you have to find the axis of symmetry, then you got to plug that number back into the equation. Then we're going to look at the y-intercept, and the y-intercept is always a value of when x is 0. And when you plug 0 back into your equation, you'll always get whatever the c value is, because the x squared will cross off, the x will cross out, and you're left with the c value. On the second page, we're looking at the steps that it takes to graph a quadratic function. One thing that we'll often do on our tests and quizzes is determine whether the parabola opens up or down. Remember, if a is greater than 0, you know that it's going to open upwards. If a is less than 0, it's going to open down. We're going to find the line of symmetry, which is always x equals negative b over 2a. We're going to plot the vertex, and you do that by plugging in the x value. We're going to find the y-intercept, and once you find that y-intercept value, which is always 0, c, then we're going to reflect a point over the line of symmetry. Then you test for another point and you reflect that one. Don't forget about your domain and range. So here we notice that the a value equals 2, the b value equals 6, and the c value equals 3. So since a is greater than 0, we know that it opens up. We know it's going to be a little narrower because it's a is greater than 1. It's going to be a little bit more narrow than the normal parent function. So now we're going to look at the line of symmetry. So negative 6 over 2 times a This one comes out to be a fraction. It's not very helpful, but it can still be done. So we come over and we graph our axis of symmetry, and we label that as x equals negative 3/2 I like to make it a dashed line. I don't want the line to be confused with the y-axis. Then we're going to plug in that x value back into the original equation. So we're going to get 2 times negative 3 halves squared plus 6 times negative 3 halves plus 3. This is for trying to find the vertex. Where does the graph exist when x is negative 3 halves? That's the question. Somewhere along here where those dots are, somewhere along there is the vertex. Plug it back in to figure out where it would be. Remember, you've got to square your fraction before you multiply it. When you're multiplying a fraction by a number, you only multiply the top. This becomes 18 fourths, but these are halves. So we're going to multiply by a value of 1 to make the denominator the same thing as this denominator. So 2 times 2, or 2 over 2, really. 2 divided by 2, we're going to multiply that to this fraction, and we're going to get 36 over 4. We need this denominator for the 3 to also be a 4. You got to multiply by a value of 1, so that has to be 4 over 4. So 12 divided by 4 is 3. 36 divided by 4 is this negative 9. And 18 divided by 4 is the result that we get here. So our y value is going to be negative 18 plus 12 more, which gives you a negative 6 over 4, which happens to be the same thing. It comes out to be negative 3 halves again. So we're going to come down our graph to negative 1.5. So we've done that. Then we look at the y-intercept. So the y-intercept is always at your c value. So 0, 1, 2, 3. You can reflect that across your axis of symmetry. So you're 1.5 units away from the line of symmetry. You have to go 1.5 units past that. Then we can test another point. You can test any point that you want. I don't have any data here for 1 yet, so I'm going to test 1. So we say y equals 2 times 1 squared plus 6 times 1 plus 3. Y equals 2 plus 6 plus 3. 8, 9, 10, 11. So when x is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, that is 2.5 units from the line of symmetry, so we have to go 2.5 units past the line of symmetry. There your parabola's pretty narrow. It's opening upwards. It has a vertex down here at negative 3 halves, negative 3 halves. We always like to write our equation. Y equals 2x squared plus 6x plus 3. Now to talk about our domain, what x values can you type in? It's always going to be all real numbers for any quadratic function. The range, though, the range this time, notice that the parabola does go below the x-axis a little bit. It goes 3 halves down below it. So y is greater than or equal to negative 3 halves. The other notation you could use it includes negative 3/2, and then it goes up to positive infinity. Move on to our next graph, where first we notice that the a value is 1, the b value is negative 2, and the c value is negative 1. We know that it is going to, let's say that the a value is greater than 0, so we know that this should open up to find the line of symmetry, which is negative b over 2a. We have negative, the b value happens to be negative, over 2 times a. Two negatives make a positive. So your line of symmetry is going to be at 1. Then we need to plug that value back in to help us figure out the vertex. We say y equals 1 squared minus 2 times 1 minus 1. 1 minus 2 minus 1. Get an answer of negative 2. So on your graph, you plot the vertex. We know that the y-intercept is at negative 1, and you reflect that point 1 unit over the axis of symmetry. Now we're going to test another point. You can either pick a point to the right of the line of symmetry, or you can pick a point to the left of the line of symmetry. It would not matter. I always like to test the next point typically to the right. So if this is 1, this is 2, I don't know what happens when x is 3, or even when x is 4. Either one of those would be fine. Let's go to x equals 4. Let's see what happens. So y equals 4 squared minus 2 times 4 minus 1. 16 minus 8 minus 1. So I get a value of 7. So when x is 4, I'm up at 7. I am 3 units from the axis of symmetry, so I'm going to go 3 units past the axis of symmetry. So we write our equation, y equals x squared minus 2x minus 1. Always write your equation. Your domain, what are the x values you can plug in? I could have plugged in any x value I wanted to. So that's called all real numbers are possible to plug into this function. The range, though, the range only goes down to negative 2. So y is greater than or equal to negative 2. It's greater than that, it goes up, but it never goes below this negative 2. The other notation that we could use is to say negative 2 and positive infinity. We put the bracket around the negative 2 because it includes the negative 2. We put a curved parenthesis around the positive infinity because you really never reach positive infinity. You always could get closer. On the third and final page for 4.1, we're looking for the minimum or maximum values of the function. The minimum is going to happen when the parabola opens upwards. A maximum is going to happen when a parabola opens downwards. The a value is negative. The a value would be positive. When you're answering the question, what is the value, what is the maximum value, or what is the minimum value, it's only the y value that you give as an answer. So when we look at this particular problem, we see that the a is -2, the b is 4, and the c is 3. So because the a value is less than 1, or less than 0, we know that it's going to open down. Therefore, it's going to have a maximum. Here's an example of a parabola that opens down. It's going to have a highest point. It's going to have a maximum point. The question is, what is the y value for that highest point? In this picture, it's 1, but what is it for this equation? So essentially, we have to find the vertex. So we're going to start out with your line of symmetry. Your b value is 4, a value is -2. So we get a value of 1. Now we have to plug that back in to the equation. So we get a y value of 5. So we know that the max value is y equals 5. It is not the coordinate 1, 5. It happens when x is 1. But when they're asking for the maximum value or even the minimum value, they're just looking for the y coordinate, which is 5. Okay, here we're going to go on a go-kart track. A go-kart track has about 380 racers per week and charges each racer $35. The owner estimates that there will be 20 more racers per week for every $1 reduction in the price. So as you make the ride cheaper, you're going to get more people to show up. How can the owner of the go-kart track maximize weekly revenue? What should the price be to maximize profit? We often think you have to increase your price, but in this case, you're going to get more riders. So you've got to think about, what is revenue? What makes your total revenue? That's going to be the number of races times what? Times the price. So if we have 380 races at a price of $35 a piece, with a calculator, we can see that that's 13,300. Now, we said that we were going to get 20 more racers. We expect to get 20 more racers if we take our price and subtract 1. So essentially we have 400 times 34, and we're going to get a price a little bit more than what we had previously. So we have a higher revenue. Now we're going to take our 380 and we're going to take our 20 and we're going to do it twice. So now essentially we're adding 40 to this. So you could say that it's 420, but I want to be sure you see how the equation is being made. And in this case, we are subtracting 1 2 times. These two numbers will always match. When you multiply this out, we get 13,860. Now you could continue this process on, and you could keep plugging in values. So if we try it again, we're going to take our 380 and our 20. We're going to add 20 to it 3 times now. That means we're going to take away our dollar 3 times. By decreasing the price by $3, we're going to get 20 more people 3 different times. And that comes out to be 14,080. We could continue this process until we find a maximum number. Or we can take our 380 plus 20 times some number, which we're going to call x. We'll take our 35 and we'll minus 1 a certain amount of times, which is that same number, so we call it x. That's going to give us our maximum profit. We don't know what our maximum profit is, so we often call that y. So to solve this, what you would end up using, a skill you had in Algebra 1, we need to make this into a standard equation because all the graphs we've done so far are in standard equation. So we're going to FOIL this together. Then you multiply the outside. Multiply the inside. Multiply the last. By reorganizing this around, and grouping your values together, your like terms, your line of symmetry is going to be negative 320 divided by 2 times your A, which comes out to 320 divided by 40, which comes out to 8. So if X is 8, so if you take off $8, you're going to maximize your profit. If they decrease the price by $8, then they will have 160 more riders to maximize profit. They could get even more riders by taking off $9, $10, or $11, but when you multiply it out, you would start to decrease your price. So you would only get your maximum value by taking $8 off.